Hello, good afternoon, everyone. I'm really glad to be here today because this is the topic that I'm very excited to be talking about today. So, my name is Olegs Gabrusjonoks. I work at a company called Silicon, where I fulfill the role of a software architect. And my personal experience with GraphQL is that I've been working with it for a couple of years now, and the way I see myself is kind of an advocate in my organization for this tool. And my personal belief is that there are many reasons why some organizations would be reluctant to accept GraphQL, but technical details are not one of those. So it's more cultural, organizational things which are challenging, but tech is excellent. So what I will try to achieve with this talk is to also convince you that if you choose to adopt GraphQL in your organization, that the tech got you covered. So the libraries and tools within the ecosystem are good enough for the job at hand. And conceptually, this is a sequel to the talk that Paul, my colleague, has given yesterday about the abstract ideas about backend for frontends, about how GraphQL can be best friends forever with backend for frontends, and the role that GraphQL plays in this pattern. But today I'm going to kind of decrease the level of abstraction a bit and show and tell more concrete stuff, like the libraries that will make your life really excellent if you use GraphQL, and the tools that make it really easy to work with this technology. And specifically, I will focus on the web technologies. So what we're going to see today is basically just a tip of an iceberg. There's much more stuff in there, but since this is a front-end conference, we'll focus on the web stuff mostly. So, to recap, a couple of things that I personally value a lot about GraphQL. The fact that it's really centered around the client needs. There is a lot of empathy going on there. So when you use GraphQL and when you write GraphQL code, you really feel like this tool that cares for you a lot, deeply, and not just for you as a front-end developer, but for you as a person. I'll show you some examples later on. So it really strives to make your life as productive and as fun as possible. It also gives us front-end developers the power to ask, excuse me, for the exact data shapes that we need and for the exact data types that we need at the given point in time. And that helps us to kind of glue together the view representation of the data that we do on the front end and the domain representation of data that we usually see on the back end. But with GraphQL, these boundaries are really blurred and kind of like work nicely together. It also makes, I believe, the front-end code quite simple and elegant compared to what we used to have in the past. So the data fetching code sometimes might get messy because of all the nitty-gritty details that come into the implementation, like, for example, error handling, retries, caching, things like that. They all had to be implemented on the client side. And especially if you like consume a very denormalized RESTful API, then you have to do a lot of network round trips back and forth between the client and server just to aggregate the data in a way that fits your view model better. And all of that wouldn't be possible without the rich ecosystem of open source tools and libraries that exist within this community. And the community itself is also extremely diverse and active. We'll be talking about a bunch of organizations that contribute back to GraphQL. So it's not just the Facebook that contributes back. They are driving the spec, they're providing their support to the community, but they're not the only players in this league. To kind of call back to the BFI presentation that Pavel did yesterday, I'll use one of the architectural diagrams that he presented to steer the roadmap for the ecosystem. So to recap, the way how GraphQL works is basically both the query language and the way how you submit queries from the client to the backend, and also the execution engine on the backend that fulfills those queries, and things in between like tools. So to kind of go from top to bottom, we'll start with the client, which is the most obvious place to start on a front-end conference and see what kind of libraries are out there that can make your experience working with GraphQL as pleasant as possible. We'll talk about the tools that you can use to explore and visualize your GraphQL schema in various ways. And we'll talk about the server implementation. And the reason why I'm talking about the server implementation for GraphQL on a FrontCon conference will become evident in a couple of minutes. Okay, so let's talk about the client libraries first. I think that, okay. Let me just talk through this. I think the visibility is quite low. So there are 3 mainstream options available to you if you want to adopt GraphQL on the client. The first one is the Apollo client by the Apollo team. This is my personal favorite. So very similar to libraries like React. It's very modular, very extensible. It's basically a set of libraries that you compose together in order to define your GraphQL experience. It is very much performance-oriented. What that means is that it gives you the tools and the means to make your GraphQL queries as fast as possible. So one example of that would be intelligent caching that they have built in. What that means is that by default, if you enable a certain configuration tick in Apollo client, Apollo will cache all the responses that you get from the backend, and once you hit the same query again, it will just basically return the data from your local cache instead of going directly to the server. It might not be unexpected behavior in all times, and Apollo gives you the flexibility to override these configs and so forth. But by default, I think the caching behavior that they do is quite sensible. One example of that will be like, for example, if you have a paging widget at the bottom of your page, and you can navigate between different pages, so 1, 2, 3, 4, 5, and then you can go back. So by default, Apollo will basically make sure that once you go back from the last page, all of the previous pages which were already fetched in the past would be fetched directly from the cache and not from the backend, which is cool. Another more advanced technique, I would say, is the batching of queries. Just to give an example, let's say you have a component A that have a data type A as well bound to it, and you have a component B that has a data type B bound to it, and eventually you figure out that it makes sense not to issue the queries to fetch data A and data B one after another or in parallel, but rather in the same network request. So for example, you're operating in a network constrained environment and would like to batch these queries together. So what Apollo client can do, again, just by ticking the configuration option, it can do this automatically without you having to change any of your business code. So all of these kind of side effects, the nitty-gritty things that you usually have to do somewhere around your business code are implemented elsewhere. So conceptually, your views and queries, they are meant pure. Optimistic UI is more of an advanced technique, but it could be useful in some cases where, for example, you feel quite optimistic about the responses from the backend, but for some reason or another, you don't want to wait for the backend to resolve your data. So you can provide some default payloads to Apollo, and it will resolve the queries immediately. And if the server-side call succeeds, nothing will change for the user, but if it fails, the user will notify it. So I think it could be a nifty trick if you want to work on your perceived performance as well. The next option is Relay by Facebook. This is one of the, well, actually the first GraphQL client out there. Technically, it's not a client, it's a library, and a quite opinionated one of that. So Relay has makes a number of assumptions about your schema. So you can just consume any schema from Relay. So from this point of view, I think it sets up a bit of a high barrier for the newcomers because it has answers to the questions that you didn't know you had in the first place. From this aspect, Apollo is quite much more flexible, I would say. And the last option, but not the least, is Urkel by Formidable Labs. This is a newcomer on this scene. And the reason why I list this guy here is to highlight the fact that even though there are mainstream options like Apollo Client and Relay, there are still some tools worked on by the community that you can use if you feel like the previous solutions don't fit your use case for some reason or another. For example, the complexity of Urkel is much lower compared to the previous options. Just to give you an example of how the GraphQL client query could look like, basically, This is where the simple and elegant part comes in. So instead of jumbling all the code, representation, querying, and so forth together, what we do here instead, we basically separate the concerns. So first we start with defining the query itself. That's the first 4 lines. So that's the query. It's a plain JavaScript string that basically describes that I want to fetch a hello field from the GraphQL backend. The next part is where you declare the actual component and define how the component should render this data, right? And the last part, what you do is you basically take these 2 declarations, the query declaration and the component declaration, and compose them together to enable data fetching. And all the ugly side effects that happen in the background will be taken care for you in this outer component, which results from the query composition. That's the React example, by the way. And I believe, like, if you're looking for some alternative GraphQL clients and whatnot, that's the kind of the model that you should look for when you compare different options, because this is really nice. Okay, so now I'm going to make the demo gods really integrate me and do a demo. So when it comes to tools, the first tool that we're going to look at is called Launchpad. Launchpad, if you're aware, if you know the JS fiddle in the JavaScript world, should look really familiar. It's basically a playground for GraphQL where you can test it out without having to set up any server-side or client-side infrastructure on your machine. So it's a software as a service offering. To break it down, there are 3 parts to this thing. So the leftmost part is your server definition that defines the schema and the resolvers that are attached to the schema. The second part is the client that you can use to submit a query to the server that you have defined on the leftmost part. And the rightmost part is basically a response from the server. So if we run it, we can see the result from the GraphQL server. So just to make a point of how easy it is to work with this tool, I will do a slight change, and we'll see how it is reflected in the response. So let's start with modifying the schema, and let's say that we want to say hello world, we want to say hello something. So we will define a message argument for the hello field over here. We'll say that it's a string. Okay, everything still works. And now let's grab this message argument in our resolver and interpolate it right into the string. Oops. Okay, there we go. So let's see. Now it prints undefined because obviously I haven't passed the actual message in the payload. So there are 2 options here. We can either say that by default message says world. Again, that happens on the schema level. So that's something that we define declaratively on the schema, and then the GraphQL execution engine fulfills. But if you want to overwrite the default value, what we can do, we can go to the client and specify something else. So for example, FrontCon. Okay, let's run this again. And here's the message reflected. Again, I did not have to set up any tooling, any server infrastructure on machine. It just works in the browser. So I really implore you to try it out if you're curious about GraphQL. That's a nice way to learn it. Okay, let's go back. The next set of tools are Chrome developer tool extensions that you can use right in your browser to figure out what's going on between the client and the GraphQL server. The reason why these tools even exist in the first place is the fact that if you navigate to a GraphQL backend, GraphQL, to the client that supports GraphQL and open up the network tab and try to figure out what's going on there. Like for example, I'm I'm at the GraphQL weekly web page, which is written in GraphQL, and I want to check out how they have implemented GraphQL on their client. So I can navigate to the request in the network tab and see that the payload doesn't look so nice actually, right? The query is just this long string that doesn't make any sense, and the variables are this weird object. The response is fine though, but it's not the response that I'm looking for. It's basically the query, because I want to learn how it works. So the first Chrome dev tool that can be helpful for you if you want to figure this thing out is called GraphQL.js. You can install it from the marketplace, and what it does basically is when you restart the web page. Demon.gods are not so happy with me today. Yeah, that's unfortunate. Let's keep it for now. But the point is that they will actually parse the request, display its structure, and you can actually see the underlying query that was submitted in a nicely formatted way. Oh, here it is. So that's the query structure. You can see what fields they query from the backend and so forth. And you can also peruse the response here. And it works with any GraphQL-enabled backend, so it doesn't matter if it's in Apollo or Relay or something else. So the next tool I'm going to show real quick is the Apollo DevTools. So besides providing the client and the server implementation for GraphQL ecosystem, Apollo guys also have created a Chrome extension that gives you insights into what's going on in your Apollo application. So, for example, here I can see that these queries have been defined on this web page. The cache state is also available here, and it really helps during the development when you're not sure what's going on with your caches, for example. You can really use it to make sense of your application. So the next set of tools that we're going to talk about real quick are the Schema Explorers. There are two options right now available in the market, both of them open source. The first one is GraphQL, cute name by the way, from Facebook. What GraphQL is, it's a web-based IDE that you can embed into your application or serve as your server that gives you insights into the schema and provides some developer experience facilitation like query suggestion and query syntax and error highlighting. So without further ado, let me demonstrate this thingy. In order to do that, I'm going to start my local GraphQL server real quick. Okay, looks like it's up. Let's go back to the index page, see if it works. Okay, here it is. So let's navigate to the GraphQL endpoint. So it looks a bit similar to the Apollo Launchpad. On the left-hand side here, you can compose your query. On the right-hand side, you can see the results from the server. And an optional documentation tab that you can expand right over here basically gives you a description of all the fields, types, mutations, and operations which are available in the schema. So let's explore this guy. We can see up front that there are two root fields. One is called jokes, another is called Star Wars. We can expand this thingy and also see how the type itself looks like. You can notice up front that this is not really useful because as I navigate, they always replace the previous context and always kind of on a single level of documentation, so it's easy to get lost, but nevertheless. And here we can actually run a query, which GraphQL will help us with, sorry. So if I start typing, they will suggest me the fields available in the schema. So let's pick Star Wars and ask the Oracle who is the actual hero of the Star Wars movies. Now I can run it and get the result back. So apparently it's R2. If you're curious, we can actually specify exactly per episode and see who's the hero of New Hope, for example. Yep, still R2. Let's try something else. Still R2. Yeah, so now we know the real Star Wars hero. Anyway, so let's try to make some mistakes here, because we're humans, so we're not perfect. So if I make a typo, if I make a typo in the field definition here, I get a nice kind of suggestion. Did you mean hero? Yes, thank you very much, GraphQL. That's exactly what I meant. And the cool thing as well is that if I ignore this warning and run this guy anyway, then the server responds with the same suggestion, right? So if you're a front-end developer who mistyped your query or asked for something that doesn't need a schema, the server will try to help you out. So it's a really empathic technology. Okay, so you might notice that some of the things that you might have expected to be on GraphQL are missing here. Specifically, the ability to specify, for example, custom headers is not there. So if you have some specific authentication needs, like OAuth tokens or whatever, you cannot really pass that thing down. So the community decided that that's not the best that we can do, and came up with another tool, which is actually based on GraphQL, but extends its functionality with the features that are really helpful for the developers. So first of all, it runs in dark mode, which I prefer. So let's copy the query from GraphQL and run it in the playground. So it's the same response, the same features like highlighting and stuff like that, but you can also specify some additional HTTP headers. And once you go over to the documentation space, you can see that it actually expands as you dive deeper into the docs, so you never get lost. So that's my personal preference. I usually stick to this one instead of GraphQL because of the developer experience improvements that it has. Okay. The weird thing that I've noticed immediately that when I started to work with GraphQL is that most of the documentation tools, even though the tool is called GraphQL, they're not really graph-based. So like you have lists, you have stacks, you have like just plain views, but you cannot see the API that you provide as a graph. So somebody had the same idea as well, and they came up with a tool called Voyager that does exactly that. So if you get lost in this kind of doc space, which you can do instead, if your server actually supports the Voyager middleware, whoops, let me zoom out a bit, refresh this guy. So what it does, it basically scans the schema, and quick reminder, schema in GraphQL is strictly typed, so there are no guesses there. You can see exact relationships between the types and the arguments that the fields require, stuff like that. So what they do, they grab the schema and create a graph view of the schema. So you can visually understand like what's going on here. So if we navigate to the top level query type, for example, and zoom in into the Star Wars field, I can immediately see that there's a Star Wars type that has this and that types and things like that. You can also go back to the left-hand side where you see the list of all the fields. And for example, if you have an enum somewhere in there, you can also see how it actually looks like, what are the values which are available there. So let's go to the episode enum, so you can see all the movies which you can pass as the arguments. Okay, so let's quickly talk about servers, because servers is what makes all this visualization and representation tools actually possible. Just a quick side note, if your server does not support either of these tools, there are also standalone apps available packaged in Electron shell, so that you can run these tools as desktop applications if you point to a correct URL. So don't worry about that. You don't have to deploy the stuff with your server. So most GraphQL servers actually consist of 4 parts. Let's do a quick breakdown. So the HTTP middleware is a thing that basically translates from the HTTP world to GraphQL world. So what they do, they take your HTTP request, parse it, extract the query, extract the variables, and find the query execution engine to run this query on. The spec defines 2 supported HTTP methods. You could do either a post or a get. If you do a post, you submit your query in the body of the payload. If you do a get, you can use query variables. The next part is the query engine. The query engine is a thing that takes your query, parses it, evaluates it, makes sure that you don't have any type issues there, and calls a resolver. And then it's up to the resolver to actually fetch the data from someplace else, return it back to the engine, and eventually make it available for the client. So basically, it's a place where you put most of your business logic at first, then you refactor. The tools with an asterisk is an optional component because it's not really required by the spec itself, but most of the servers that we have worked with so far provide some additional goodies on top of the bare bone server implementation. Things like GraphQL, Voyager, tracing, and so forth. We'll see a couple of these tools later on. So just like with the clients, there's a bunch of options when it comes to GraphQL servers. Again, we see something from the Apollo guys. So by now, I think we can deduct that they provide a full stack GraphQL experience. So personally, that's why I kind of mostly use their tools, because it makes sense to do this full stack thingy from client to the server to the tooling. We have Express GraphQL, which is a bare bone connect style middleware server developed by Facebook. And actually, most of the other tools are heavily influenced by this guy. And we have a server called GraphQL Yoga by the team called Prisma that does some software service stuff for GraphQL. They basically took Apollo server and made it even better. Added some additional tools like Playground, and minimized the amount of configs that you have to do in order to get up and running with GraphQL. Which is weird because this is this snapshot, the snippet that you have to add to your Node.js app in order to boot up the Apollo server, which is not that much. So I wonder what the Yoga guys are doing here. So this is relatively straightforward. You define a schema, you create a middleware engine, and you bind certain URL segments to the GraphQL Express middleware, which is provided by the Apollo server. That's it. All of the magic is built in. We have a couple of minutes left, so I really want to talk about this one. You might be wondering why exactly we're talking about the server libraries on the FrontCon conference about GraphQL, and the reason for that, I think, is hidden in one of the first slides, slide number 6. I said that with GraphQL, your client code becomes simple and elegant, right? So whatever ugliness and complexity you used to have at the fetching, that data fetching layer just goes away. But it doesn't just disappear, right? It goes away somewhere. And I guess most of you can figure out where exactly they go. The backend. So overfetching, underfetching, all of these things moved away from the front end to the back end. Like this one, for example. Let's imagine we have a couple of fields which have a one-to-many relationship, and the outputs of the first field are fed into the resolvers of the second field. Like in this example, we select posts, and then for each post we get comments. A naive GraphQL server implementation does this by default. No way around it. It's not really optimal, right? So if you want to really bump up your cloud bill, that's what you want to do. But otherwise, please don't. The second issue, which is also quite relevant, is the duplicate requests, right? You can do this feature in GraphQL is called aliases. You can do the same query with different aliases, which results in the same server dependency calls on the backend. Not really optimal as well. This is a really fun one. So we said that the client can define the exact shape of the data that they will get from the server, which doesn't mean that the clients are supposed to be playing nicely, right? They can be malicious. You could submit a query that just basically kills the backend. Or you could just make a mistake and kill your own server. So the first tool that can help you with that is Apollo Tracing. It's an extension into Playground that basically breaks down the performance of each individual resolver. Let me go back real quick. You can enable if you click on the tracing tab over here. But I only have a single guy, so let me pull something up from a history, run it. Yep, the demo gods are not happy. But the point is that you will see the actual performances of each resolver. That will help you to pinpoint the issues, but in order to solve those issues, just real quick, you can use a tool called Data Loader. It gives you an API to solve that, so Facebook got you covered. As for the denial of service attacks, there is a plugin for the server called GraphQL Cost Analysis, which can compute the complexity of your query and reject it if the threshold is reached. So you can basically say that the client cannot fetch more than 1,000 fields. That's it. Okay, so I guess that's it. Thank you very much, everyone.
Yeah.